Ever wonder how robots or AI systems really make sense of the world? It's not just about seeing, it's about understanding change over time. Imagine a robot reaching for a moving object or a self-driving car predicting what's coming next. That's where Token Bottleneck, ToBo, steps in, and it's rewriting the rules of how machines learn from dynamic scenes. Let's start with the problem. Traditional AI is like a superhero with a blind spot. It's amazing at analyzing a single image, but it struggles with sequences. Think of it like trying to read a book by only seeing one sentence at a time. You'd miss the plot. That's why robots often stumble when tasks involve motion, like opening a cabinet or stacking cups. Enter ToBo. Here's the clever trick. It compresses an entire scene into a single bottleneck token, a mental summary note. Then it uses that token plus just a few hints from the next scene to predict what comes next. It's like having a memory chip that holds the essentials, then using a few clues to fill in the gaps. The magic happens when the model is forced to rely on that bottleneck token. It learns to embed temporal dynamics, not just patterns, but motion, transitions, and context. It's like teaching a robot to recognize that a door is still a door, even if part of it is hidden behind a curtain. So how does this work in practice? Researchers tested ToBo on real robots, like the Franka Kitchen, which simulates tasks like opening cabinets or manipulating objects. The results? In simulated environments, ToBo outperformed older methods by 20% or more. On real robots, it achieved 65–80% success rates in tasks like cup stacking, a huge leap from previous techniques. But here's the real twist. They applied the same technique to a UR5e robotic arm, a real-world system used in manufacturing. Instead of relying on complex sensors, they gave it just one camera view. Think of it like teaching a kid to ride a bike by showing them a video, not by giving them balance sensors. The robot learned tasks like opening cabinets or stacking cups, and it nailed them with impressive success rates. This proves the method works outside the lab, which is a huge deal. What makes ToBo special? It's not about brute force. By masking parts of scenes, like covering most of an image with black squares, the model learns to focus on the most critical clues. This forces it to reason about what's changing, not just what's there. For example, if a cup moves in a video, ToBo doesn't just note its position. It understands the trajectory and predicts where it's headed. Why does this matter? Better visual learning means robots can adapt to messy, real-world environments. Whether it's a warehouse bot sorting packages or a home assistant tidying up, ToBo's approach makes AI smarter, faster, and more reliable. And the implications go beyond robotics. Improved video analysis could make self-driving cars safer by helping them read traffic patterns or power smarter augmented reality experiences. So what's the takeaway? This research proves that robots can learn complex tasks efficiently by focusing on visual data alone. It's a step towards smarter, more adaptable machines that can handle real-world chaos. And hey, who knows? Maybe your next smart assistant will learn by watching YouTube. Thanks for watching. If you want to dive deeper into how AI learns from time, hit that subscribe button. Stay curious.